Hello, and welcome to Integrating Mathematics into Out-of-School Time. I'm your host, Doreen Grasso, the Executive Director of Always Learning Rhode Island. So let's get started. I'll tell you a little bit about me. I am a former middle school math teacher. I taught at Rhode Island College in the elementary education department, and I did over 20 years of out-of-school time. So I think I can give you my expertise on how to integrate mathematics into your out-of-school time programming. We'll talk a little bit about who we are and what we do and why the focus is on math. I put pause buttons throughout this presentation. If you'd like to pause to take notes or have a discussion, feel free to do so. Let's get started. Always Learning Rhode Island is here to support and advance the learning for Rhode Island youth by augmenting the 180 days of the traditional school schedule to provide opportunities for year-round, out-of-school learning in homes and in the community. We want to increase the number of learning days from 180 to 365, provide important and useful tools for at-home learning, and improve our community education programs and opportunities. It's all part of the Learn 365 Rhode Island, where every home, every day, learning matters. So when we talk about community education programs, we're talking about you. And we want to thank you for all you do for the students in Rhode Island. Our goals by the end of this presentation are to learn ways to integrate math into out-of-school time programs, make connections between your content and math, and make a plan to incorporate more math into your program. Math is everywhere. There's no avoiding it. So one of the things that young people find out once they graduate from high school and college is math continues throughout your lifetime. So what is your reaction when we mention math? Think about this. Are you confident? Just okay? Curious? Unsure? Nervous? Or just plain afraid? So think about this. Reflect on your feelings surrounding math. What are your positive or negative experiences that you've had in your life that may influence how you feel about math today, whether it was in school or out of school? We're here to help. We want to suggest, though, that check any negative perceptions at the door. We want children to embrace math and its challenges and have that growth mindset, because math stands for mistakes allow things to happen. So write down what your experience was in mathematics. Take a moment here. So you may have heard of things around the schools about course standards and curriculum frameworks and RIDE-CAST testing and competencies. You can look up all sorts of frameworks at the RIDE website. The math standards on the right, numbers and operations, measurement, statistics and probability, geometry, algebraic thinking, expressions and equations, ratios and proportions, and functions are all part of the curriculum framework. The good news is you don't need to be a math teacher to teach students the importance of using math outside of the classroom. Teach them, point these things out. Put math to work inside your program and demonstrate how the skills that they learn in school are applied to accomplish tasks in your program. Take a moment and think about it. There are skills like measuring and calculating, problem solving, estimating, using technology, logical and critical thinking. Take a few moments and write down what you think that you can utilize or already utilize in your after-school, out-of-school time programming. You already do them, so it's not a worry. So let's look at problem solving. Poya had these 4 steps: understand, plan, solve, and look back. But it is a process, and most likely your students already solve problems within the context of the work that you do in your program. So that may be planned by you. It might arise during your teaching. but take advantage of these opportunities to problem solve. Engage students with guiding questions such as, what do we know? What's the problem? That's the understanding part. What do we need to know? So now you're moving from understanding to a plan. How can we find a solution? Let's do it. Solve and carry out that plan. And then look back. Very important. Did it work? Review and analyze your results. One of the things I have to say about the problem-solving process is it's not a linear process. It says 1, 2, 3, 4, but sometimes you loop back with that. So once you get to the end and start looking back, you might go back with a different understanding and start from the beginning again. You might go back and devise another plan or look for another way to solve it. The point is to keep on trying. It's an ongoing process, and you want to persist through. Hoya said, it is better to solve one problem 5 different ways than to solve 5 problems one way. So you've also might have heard this thing PBL, problem-based learning. In fact, most likely you already do it in your out-of-school time programming. PBL is a student-centered teaching approach where students learn by actively engaging with real-world problems or situations, fostering critical thinking, problem-solving skills, and collaboration. It's student-centered, so there's a lot of student choice or self-directed learning, authentic situations, challenges with problems or questions, sustained inquiry, and the reflection process. Out of school time is the perfect place for problem-based learning because it's a safe environment for risk-taking and exploring. So how might problem-solving or PBL show up when you're teaching your program activities? Take a moment and write that down. I'll use myself as the first example. I taught a cooking and eating class for about 20 years in Providence. So we used math all the time. I made sure I incorporated it. Whether we were looking at nutrition labels, we were looking at fractions with measuring, we did grocery shopping and budgeting and per unit pricing. We looked at recipes and looked at the yield. If we had a classroom of 12 students and the recipe was only for 6, we had to multiply and by 2, including multiplication of fractions. And then there's the whole timing portion of it. So we were doing a lot of calculations. There's the unit pricing there. We looked at proportion and fractions, even with nutrition. So I took the pyramid and we looked at it as a circle in fractions. And then data and statistics are everywhere. Anywhere there's numbers that you can count, we can use data and statistics. I'll give you a good example. We did a consumer report on what is the best blueberry muffin. So each time we would do this, we would take 3 or 4 different types of brands and we would cover up what the brands were and look at which one was the blueberry muffin. So it has to be all the same. The only variable here was the brand. So students developed criteria. All these math terms are highlighted here. Criteria, which is a characteristic by which to judge or evaluate. They developed a scoring rubric with a scale. They taste tested products using that one variable, which was brand. They individually scored, tallied, and averaged, which is a mean, their data, that information, to find the best overall score and the best blueberry muffin. So we needed calculators, pencils, and then when we used grid and graph paper at the end to do visuals. Here are my 2 pages here. So we talked about doing consumer reports testing. So the students developed criteria that they could judge. They came up with their scale. They tallied their scores. They calculated averages. And then at the end, they graphed their results. I have never seen students more engaged in mathematics because they really took it seriously. They even put it in their mouth and tasted it all at the same time. So these are just an example of some that we've used here. Um, each student group made a different brand of blueberry muffin, and then they rated it by judging by their criteria and their scoring scale that they came up with, and they show here they're tallying their results. Once completed, the students had the data they needed to create their visuals. A very engaging process. It did take a couple of days. So the statistics engagement here, what's involved? So you can talk about data, mean, mode, median, scale, proportion. We're taking a sample of a population. But over to the right-hand side, it doesn't have to be cooking. You could take a survey or a poll of a topic related to your program. What's your favorite blank? Anytime you can start counting student answers, you can do some kind of statistics. Collect some performance data, something that they do. You could do polls. You can predict. How many things do you see or find? What do you think we'll find? Use data collected to make graphs. Get those visual representations. Use things like an X and Y axis and a title and a scale. And then have a discussion about what the results are and how they influenced their thinking. One of the things that teachers find in classrooms is they don't have enough time to reflect. The beauty of doing stuff in out of school time is you can incorporate that into your teaching and get some really rich results from students. So let's look at other out of school time activities. So I divided it into 4 groups: STEM, sports and physical activities, arts, and outdoor activities. The STEM already includes math by definition, so math is the language of science, so we're just going to check that off and skip that, and we're going to focus on sports, the arts, and outdoor activities. Math skills in sports and physical activities are huge. There are a lot of statistics that you can do. You can do calculating, averages, percentages, use graph and tables, physics formulas. You can look at arc and trajectory and velocity and acceleration. There's scorekeeping in every sport. You can record the data. You can compare stats, use predictions, analyze. Geometry is used with shapes and formations, triangles, lines, circles, angles, they're everywhere. Fractions. Games are divided into innings and sets and quarters. Divide the fields up into fractions, and then maybe look at that conversion between fractions and decimals and percents. And last, timing. Use stopwatches, compare, predict, estimate timing. There's a lot of ways you can incorporate math into sports and physical activities. Stats are the greatest numbers in sports. When you think about it, the old baseball cards, students can actually make their own cards nowadays with apps. You can look at scoring. You can look at free throws. How far did someone jump? Baseball statistics, any kind of sport that you can think of. Students are used to looking at stats and seeing stats, especially on television. So they might not realize it, but students already know other sports math, like geometry. For instance, if they're kicking a goal into the goalie, or we look at this one, how are they going to hit the ball in a volleyball, especially on a serve? They may not think they know a lot about geometry and circles, but they certainly know what a 720 is when someone does it in snowboarding. And if they're playing tennis, they know what angles to hit to try to beat their opponents. Let's now think about how mathematics appears in the arts. If you do any kind of art programming in the out of school time, You could check out our other video that's mathematics in the out-of-school time arts programs. That will give you more of an in-depth look of how you can integrate the arts and mathematics. But for here, we're just going to highlight some of those. In the visual arts, there are lots of connections. Artists are always using lines and angles and circles, which all can be measured. They have geometry and shapes. Up above, you see someone doing a drawing with 2-point perspective. You use the golden ratio for drawing faces. On the bottom left there, you can use the angles to create a foreground, middle ground, and background. There's the Fibonacci sequence that shows up in nature. There's symmetry and balance. And then there's moving from 2-dimensional to 3-dimensional design, which brings in volume, and graphic design. So there are all sorts of ways that you can integrate mathematics with your arts programming. Then there's performance arts and dance. Timing, of course, is key when you're dancing, especially with a group. So important. But there are also lines and angles, balance, and rotations that you can think of during the performance art, and keeping to that beat. When we start looking at music, math is everywhere. It has something to do with timing and tempo, the tone, a count, rhythm, scales, a beat, patterns, and even ratios, fractions, and symmetry. So whether you're mixing music, singing, writing lyrics, playing, or learning an instrument, math is definitely involved. Moving to outdoor activities, there are so many things that you can do outside. Anything you do outside, whether it's looking at nature or doing a cleanup at a park, there's data collection. You can do weighing and measuring. If you're working in a community garden, that's a grid, that's area, perimeter, square footage, more measuring. Data collection on animal behavior, looking at birds. There's games that you do outside. There's scoring and counting there. You can do physics, geometry, statistics. Think about an arc when you pull an arrow. Maybe you're in a sailing group. There's speed, velocity, navigation, fluid dynamics, or any kind of orienteering. Grab a compass. You can look at grids on a map, directionality, angles in the compass work, scales, distance, estimation, spatial reasoning. Many connections here. So are your ideas flowing now? Maybe we didn't cover your specific program, but I'm sure we mentioned some math connections that you can use. So think outside of the box. Here are some takeaways. You don't need to be a math expert. Just show its application. You can connect math to your program. And if you have questions, contact me, Doreen Grasso, at info@alwayslearningrhodeisland.org. I will give you some suggestions. Now it's your turn. You can do this, and you can integrate mathematics into your out-of-school time programming. So I want to thank you for your time today. I certainly appreciate it. It's a very important initiative that we're starting this year with Math Matters Rhode Island, but we want this to continue throughout the years to come. So check us out at alwayslearningri.org. Follow us on Facebook and Instagram, and check out our YouTube channel, because math really does matter. You can count on it. Thank you very much.